Greetings, everyone. I hope you're doing well today. I still remain your regular host on this pathology class, Dr. Nuhujon Uchenna. And in today's class, we're going to be doing something very, very tangible. We're going to be discussing another protozoa parasite that is called Balantidium coli. So, we're going to be talking about Balantidium coli. And the first thing I want us to understand about this parasite is that first is the largest protozoa parasite that infects the intestine, or the largest intestinal protozoa parasite. And apart from being the largest intestinal protozoa parasite, this parasite is also a ciliator or a ciliate in the sense that it uses cilia for its locomotion. Now, apart from the fact that it uses cilia for its locomotion, it is the only parasite within this ciliata, the only ciliate that is a parasite. When I say ciliate, I mean a parasite or an organism that uses cilia for the purpose of locomotion. Like we've discussed other protozoa parasites like Plasmodium uses undulating ridges, or have Giardia like Leishmania, like Trichomonas, like Trypanosoma. These ones use flagella. Then, of course, the Sarcodina will have Entamoeba isolatica. It uses pseudopodia, the first feet, for the purpose of locomotion. So, but Balantidium coli is the only parasite that uses cilia for the purpose of locomotion. Of course, we have other free living ciliata. For instance, Paramecium caudatum is a free living organism, is under Xerophora, but it's not a parasite. Of course, you know that an organism can either be a parasite or a free living organism. So this Balantidium coli was discovered by this man called Malstem in the year 1857. It was discovered in the dysentery stool of two different individuals. So note that this was the scientist that discovered this parasite called Balantidium coli. Now, as we progress, the next thing I want us to also look at is the classification of this parasite. Now, the final one of this parasite is Pseudophora. Can you see cilia, seal indicated here, the Pseudophora? Then, of course, we have the class Kinetophragminophoria, is a bit long. Kinetophragminophoria, Kinetophragminophoria. Then we have the subclass Vestibulifera, Vestibulifera. Then we have the next one, the order Trichostomatida. Then we have family Balantidae. Then, of course, we have the genus Balantidium. Then the species is now Balantidium coli. Don't forget, in writing scientific name, you underline the genus name and also underline the species name. Okay, now this will now lead us to the life cycle of this parasite called Balantidium coli. Now, coming to the life cycle, now the first thing I want you to also understand is that the life cycle of this parasite is synonymous to the life cycle of Entamoeba isolatica. So it starts with the ingestion of the infective stage. The infective stage in this case is a cyst. A cyst. So that cyst is like a shell that covers the parasite. So is implicated in Balantidium coli and also in Entamoeba isolatica. So the infective stage is the cyst. Now, this is usually found in the external environment. You know, either uh, on vegetable or possibly being carried by a mechanical vector. I think I mentioned this when I was talking about the life cycle of Entamoeba histolytica. So it's the life cycle begins by the ingestion, not ingestion, but ingestion of the infected stage, which is a cyst. Now, once it is ingested, then the next thing that happens is that a cystation occurs. And I know there are two different terms that I explained when I was explaining Entamoeba isolatica. I said that we have what we call encystation and excitation. Now, when it's excitation, that means that the cyst is breaking, the cyst breaks and releases the parasite. Then encystation, En, means that the cyst covers the parasite, and that is because the parasite is about to leave the interior part of the host, or the inside of the host, into the external environment, and in this case it will be exposed to adverse environmental condition, and because the parasite wants to continue to propagate its life, then of course a lid, or a covering, something like a cyst, a shell, covers the parasite so that it will help to elongate its life in the external environment. Now, so after injection, the next thing that happens is that that cyst, we are not talking about the breast. Once it breaks, and this excitation occurs in the small intestine, however, the multiplication of this parasite occurs in the large intestine. So it exceeds the ciliate, comes out, and once it comes out, then it multiplies in the large intestine. Now, after multiplication in the large intestine, the next thing that happens is that there will now be conjugation. That means that there will be a kind of exchange of genetic material. This is also called syngamy. Mm? It's a form of syngamy, conjugation in protozoa. So the micronuclei unite in this process, and conjugation occurs. After conjugation, is also important you understand that there is no increase in the number of the parasites as a result of conjugation. The parasite remains the same. So after the conjugation, the next thing that happens now is encystation. Now the parasite, uh, gets itself encysted. A cyst now covers the parasite, and once the cyst is formed, it does not turn back uh, to a trophozoite in the body of the host. Of course, when this excision occurs, then the stage of the parasite that is released is what we call the trophozoite, and this trophozoite is the invasive stage of the parasite. Now, this parasite exists in two stages. It's important to note that the first stage is, of course, the cyst I've mentioned. The second stage is the trophozoite. The trophozoite. The trophozoite is the invasive stage of the parasite. Now, uh, I've explained that it starts with injection of the cyst, then excitation occurs to release the trophozoites. Then the trophozoites, of course, undergoes multiplication and undergoes conjugation, then excitation occurs. And once excitation occurs, that means the cyst covers the trophozoites. And as this cyst covers the trophozoites, then it now passes out with the feces into the external environment. And from that, it's the cycle continues, because of course, if somebody who is suffering, the name of the disease is balantidiasis. Name of the disease is balantidiasis. So if someone is suffering from balantidiasis, and the person defecates on the ground, now fly can perch on the feces and also perch on the foot of a susceptible host. And when the person now takes in the food, or possibly the feces of someone who is suffering from balantidiasis, may be used as a kind of manure in the farm. It can contaminate vegetable, and if someone takes this vegetable without cooking properly, then of course it could also be an avenue of taking in the seeds of these parasites, and the cycle continues. So this is the life cycle of Balantidium coli. Now, after looking at the life cycle of Balantidium coli, the next thing we'll now look at is the the pathology. The pathology. Let's look at what this parasite causes. Now, this parasite is usually harmless. Even when somebody develops symptoms, sometimes it clears within a few days. However, in rare cases, now this parasite does something, and that thing it does is that it releases an enzyme. That enzyme is called hyaluronidase. Hyaluronidase. Now, once this enzyme is released, then what it does is that it a kind of causes injury or ulceration. We use the word ulceration. It causes ulceration. Hmm? Ulceration. It causes ulceration on the mucosa, on the submucosa of the parasite. Of course, the trophozoite stage is the one that releases the enzyme. Now, this is the invasive stage. It can go to lyse the mucosa or the submucosa of the intestine. And once this thing happens, then the individual would have developed what we now call ulcer. Ulcer. So that is one of the things that the parasite causes. Then, of course, the individual may, begin to experience dysentery, or may be passing out dysentric stool, as the case may be. So, but outside this, this parasite does not cause any harm that is too dangerous. Okay, now coming to diagnosis. Now, the diagnosis is done through stool examination. Now, some people also use the biopsy where there's an instrument called zygmoidoscope. Zygmoidoscope. So, this instrument can also be used in diagnosis when you're using the route of biopsy. Then, of course, culture. People can also use culture, but the commonest method is microscopic examination of the fecal sample, the feces, or you can say a demonstration of the presence of the parasite in fecal sample. Now, in chronic cases or in carriers, you may likely see the cyst of this parasite. But in acute cases, then of course you are likely going to see the trophozoites of the parasite in the fecal sample of such individual. So you use microscopy, you can use the biopsy method, you can also use the culture method. That is the method of diagnosing this parasite. Then of course treatment. The treatment is you use the same drug use in what I talked about or that people use for intestinal amoebiasis. Intestinal amoebiasis is a disease that is caused by entamoeba isolatica. So the drug of choice, which we talked about in the previous class, is metronidazole. Metronidazole. So this is used for treatment. It can also be used to treat this particular disease, balantidiasis. Then, of course, uh, epidemiology, the spread of the disease, the same method by which entamoeba isolatica spreads is also the same method that this parasite spreads. So you can go back to all the methods I mentioned, that can help to spread the disease. Fly can help to spread this, like I said. If someone is suffering from balantidiasis, the person defecates here, then fly can perch on it and also perch on someone's foot. Circulating banknotes. The bus conductor who is suffering from balantidiasis probably goes to toilet to defecate and possibly did not wash his hand very well. If he uses the same hand to give you your notes and you go to take food without properly washing your hand, you can also get infected. So we have other means of getting infected by this parasite. So that is the epidemiology and so on and so forth. So I think with this, okay, I forgot to mention that the reservoir host for this parasite is the pig, or say the primary host. The reservoir host, the primary host. Then man can also be infected, but man is usually called the incidental host. The primary host for this parasite is the pig. So I think this is how far I can go in talking about Balantidium coli. So we'll meet in the next class. I remember I almost said Dr. John Chena. What you do for me is to share this video, this teaching to people that we need it. Thank you so much. See you in my next class.